All right, so now we are going to be covering the 2021 AMC 12A. I hope you guys really enjoyed the test. I thought there was a lot of great questions on it. A few that were like, what? And then, I'm sure you had the same experience. As for my prediction for the cutoff for the AMC 12, I don't know. Something over 90. Probably, I don't know where exactly in that range. I haven't given it a lot of deep thought yet or analyzed it too much, but probably over 90 is a guess. They could have a lower cutoff because they might take a higher percent again. But my prediction for top 5% would be above 90 somewhere. I don't know. I'll probably pick something more specific later when I have time to think about it. Okay, so let's get started. What is the value of this expression? Just do it, right? So 1 plus 2 plus 3 is 6, 2 to the 6th. That's 64 minus 2, just be careful, 2 plus 4 plus 8, 10, 14, 64 minus 14, be 50. Let's get to problem 2. All right, continuing on to the AMC 12A from 2021, problem number 2. Under what conditions is the square root of a squared plus b squared equal to a plus b true, where a and b are real numbers? Okay, so usually you're taught you know that square root of 3 squared plus 4 squared does not equal 3 plus 4, right? But are there any times it could be true? Well, that's the goal. Let's just see what they say. It is never true. I don't know. Let's just leave that one alone for now. B, it is true if and only if the product of A and B is 0. Let's think about that. If the product is 0, one of them is 0. So let's plug 0 into this. What would it say? Square root of b squared would then equal b. Well, that could be true, but it's not always. You might not know it. This is the definition of absolute value, right? Or it's actually equivalent to absolute value, not the definition. So it's equivalent to absolute value, which means, or not x, but b. It means that it could be plus or minus. So for instance, if I put negative 4 in here and squared it, it would become 16, square root would become 4, not negative 4. So B seems like it's not enough information, but it's a really good trap answer if you're not thinking about the negatives. C, it is true if and only if the sum of these is greater than 0. Well, here's a sum that's greater than 0, and it's not true for that one. D, it is true if and only if, we see this one again, but another qualifier, a plus b greater than or equal to 0. Now think about this. If one of them is 0, like a, that would mean b is greater than or equal to 0. So as long as b was greater than or equal to 0, we don't have to worry about the absolute value, and it would be equal. That's why the answer is D. It's definitely not always true, and it's not never true now as well. So this is going to be it. That's the best answer. On to problem 3. So this is the 2021 AMC 10A. It was problem 3. Also the 12A problem 3. The sum of two natural numbers is 17402. One of the two numbers is divisible by 10. So if it's divisible by 10, okay, so let's just say it's a 5-digit number, I guess. We'll see. If the units digit of that number is erased, the other number is obtained. So most likely you're going to have to take something away from a 5-digit number, get a 4-digit number. So like the 5-digit number would be A, B, C, D and end in 0. That's not an O. The other number after I take the O away would be A, B, C, D. Okay, now already you don't want to really write this in expanded form because it doesn't look fun. So that's kind of your sign that you're probably up a wrong tree. What you're going to want to do is probably just think about, change what this means, right? They said the units digit, or one of the two numbers is divisible by 10, and if that units digit, this one, is erased, you get the other number, right? So then that would mean that this is merely 10 times this number. So why don't we call this x and we call this 10x? And then it says, what is the difference of these two numbers? And if the sum of the numbers is 17402, so it must mean 10x plus x, 11x is 17402, Well, we're just going to do the division real quick. 17, 4021, 11, 6, 4, 5, 55, 9, drop the 0, get an 8, 88, 2, 2 goes in twice. You get 1582 for x. So this number is 1582, and the other one is 15820. Now you could subtract and get 9x because it wants the difference, but do you really want to do that? Maybe you could check all of them and see which one is a multiple of 9, but just subtract. Don't get too cute, right? So 10 minus 2 is 8, you had to borrow 1. 11 minus 8 is 3, you had to borrow 1. 7 minus 5 is 2. We go up here, only one of them ends in 238. The answer will be D, 15 minus 1, 14. See you guys in the next problem. All right, continuing on, the 2021 AMC 10A problem 7. It was also the 12A problem 4. They haven't had this type of question in quite some time, which is why I really liked it. It's basically pure logic. Maybe you could do a Venn diagram kind of thing, but it's not really like hardcore strictly math, okay? So you might have spent some time on it, maybe you didn't. Tom has a collection of 13 snakes, 4 of which are purple and 5 of which are happy. This sounds like one of those memes where it's like they're, reminded of what they learned in algebra or something, and it makes up some funny question because, it doesn't really make sense, right? So 4 are purple, 5 are happy. He observes that all of his happy snakes can add. So I'm going to immediately go to that Venn diagram idea. So add would be here and the happy would be here. Incidentally, I guess we know what kind of snakes they are. I mean, they're obviously adders. So none of his purple snakes can subtract. So let's say this is going to be the ones that can add. This will be ones that can subtract, and purple is not going to be in there, but let's hold off just a second. All of his snakes that can't subtract, which are the purple, some of them at least are purple, so the purple snakes are part of the group that can't subtract, and all of those snakes that can't do that also can't add. So purple cannot be inside of the add column at all. We'll put it here. Which of these conclusions can be drawn about Tom snakes? A, purple snakes can add. We just cleared that up. No, they cannot add. B, purple snakes are happy. Well, all of the happy snakes are in the add circle. So the purple snakes are not going to be part of that group. Snakes that can add are purple. No, they're not. The first 3 are pretty easy to eliminate. The last ones, maybe a little bit more challenging. So happy snakes are not purple. Happy snakes, all with an add. Purple snakes out there. Looks pretty good to me. It's probably D. Because we're so close to the end, I would probably check the last one. Happy snakes can't subtract. Well, again, all snakes that can't subtract can't add, and happy snakes can add. Definitely not E. Answer choice D. See you guys in the next problem. And continuing on with the 2021 AMC 10A problem 8, it was also the AMC 12A problem 5. When a student multiplied the number 66 by the repeating decimal. That reminds me, if you watched yesterday's video where I explained, I think it was the 2019 10A, one of the problems on there, it had repeated decimal. It probably gave you a little edge on this because you just recently thought about the concept. So he multiplied 66 by this. It's AB, dot, 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 meaning it keeps going forever. This is the repeated symbol, okay? Where A and B are digits, he did not notice the notation. So what did he was supposed to do something, right? He was supposed to do 66 times. It's going to be the 1 plus the repeated decimal. And one of the things that we learned in that video is that, for example, if you have 0.41 repeating, it's just 41 over 99. If you want to know how that works, watch that video, the end part of it, where I go through a problem with repeated decimals. I show you why that's the case. So 1 plus, and it would be AB, but you don't want to write AB over 99 because it looks like A times B. Instead, we're going to need to use the expanded form, which is 10a plus b. You might not be used to this. It's kind of a basic fundamental part of number theory, which is going to be essential going forward. So this is going to be 10a plus b over 99. Okay? And again, to understand this, think about the 41. How would you write 41? It would be 40 plus 1, which is 10 times 4 plus 1, right? And that's why it's 10 times the first digit plus the second. Okay, you got it. All right, so he did not notice, just multiplied 66 times this. Now this is what he did, but he was supposed to do that. So, or it doesn't say he, I guess. Yeah, he, I guess it does say he, good. So it's going to be, he did this, 66 times 1 plus, now what's point AB? Well, it's just hundredths. So it's going to be 10a plus b over 100. All right, that's what he did. This is what he was supposed to do. Later, he found that his answer is 0.5 less than the correct answer. So this subtracted from this is going to be 1/2. 0.5, 1/2, same thing. Okay, my first thought, let's factor out this 66. So I'm going to write 66 here, and I'm going to take this and look at that and imagine moving the minus onto that 1. The 1's are going to cancel. Then I'm going to have this expression minus that expression, and they're not going to combine unless they have a common denominator. So I'm going to make one right now, 9900. Meaning I'm going to multiply this 1 by 100 over 100. So 10a times 100 is 1000a plus 100b over, it's 100 over 100, so the 99 gets it also. That was the entire point, minus, and we're going to do this one times 99 over 99. So you're going to get 990, I'll keep it in the parentheses for now, 990a plus 99b over 9900. Okay, so we got that going on. It's still all equal to 1/2. Now we have common denominator. We're going to distribute this minus sign. 1000a minus 990a is 10a. There's still this 66 out front. 100b minus 99b is b. Wait, that looks familiar. That's the number ab. And it says, what is the 2-digit integer ab? So since these are equivalent values, this is the answer when we get it. Okay, so then this is over 99 times 100. Why did I change it to 99 times 100? Because I anticipated the 33 factor canceling on both. So 33 goes into here twice, 33 goes into here 3 times, 2 goes into 150 times, and you're now going to have what you want over 150 equals 1/2. Multiply by 150, half of 150, 75. Answer choice E. Hope you enjoyed the problem. We are on to the next one.